What is energy, and why is it so crucial in our lives? This is a question that often arises in our minds. Well, let's unravel this mystery together. Energy is the capacity to do work or produce heat. It's like the invisible force that powers everything around us, from the smallest atom to the vast universe. It's what makes the wind blow, the sun radiate warmth, and our hearts beat. It's the driving force behind every physical process, big or small. Energy exists in various forms, each unique and fascinating in its own way. It might be flowing as electricity, stored as potential energy, or even radiating as light. Each form of energy has its own role to play, its own story to tell. Energy is not just a concept, it's a fundamental part of our existence. Now let's dive into the different types of energy. First, we have kinetic energy, the energy of motion. Picture a busy highway, a gusty wind, or an apple falling from a tree. All these scenarios illustrate kinetic energy in action. The speed of the cars, the force of the wind, the velocity of the falling apple. They all possess kinetic energy. But what exactly is kinetic energy? Simply put, it's the energy an object has because it's moving. And the amount of kinetic energy an object has depends on two things: its mass and its velocity. Bigger, faster objects have more kinetic energy. That's why a truck barreling down the highway has more kinetic energy than a bicycle pedaling along a park path. In a nutshell, kinetic energy is all about movement. The faster an object moves, the more kinetic energy it has. And even when things seem still, there's kinetic energy at work on a microscopic level, with atoms and molecules buzzing around. That's kinetic energy for you, the energy that keeps everything in motion. Now, consider potential energy, the energy that's stored and waiting to be used. Imagine a book high up on a shelf or a bow with an arrow, pulled taut and ready to release. These objects may seem static, but they're brimming with potential energy. Potential energy comes in a couple of flavors: gravitational and elastic. Gravitational potential energy is all about height and mass. The higher and heavier an object is, the more gravitational potential energy it possesses. Think about that book on the shelf again. If it falls, it's going to put a dent in your coffee table. Now, elastic potential energy is found in objects that can be stretched or compressed, like a coiled spring or a stretched rubber band. The more it's compressed or stretched, the more potential energy it has. Just imagine a catapult ready to launch. Remember, potential energy is all about the future. It's just waiting for the right moment to transform and do some work. Potential energy stored today could be kinetic energy tomorrow. Next up are thermal, chemical, and electrical energy. Let's start with thermal energy. This is the internal energy of a substance due to the motion of its atoms and molecules. It's responsible for the temperature of a substance and can be transferred as heat from hotter to cooler objects. So, when you feel the warmth of the sun on your skin or the heat from a blazing fire, you're experiencing thermal energy in action. Now let's move on to chemical energy. This type of energy is stored in the bonds of chemical compounds. When chemical reactions occur, this energy can be released or absorbed. So, when you eat a meal, your body is extracting the chemical energy stored in the food and using it to power your body. And when you turn on a battery-powered device, you're tapping into the chemical energy stored in the battery's compounds. Finally, we come to electrical energy. This is the energy associated with the flow of electric charge. It can be generated by converting other forms of energy, such as mechanical energy or chemical energy, into electrical energy. So, when you flip on a light switch, you're using electrical energy that was likely generated at a power plant by converting another form of energy, such as the chemical energy in coal or the kinetic energy of wind or water. From the heat of a fire to the electricity that powers your devices, energy is everywhere. It's in the food you eat, the wind that blows, the water that flows, and even in the very atoms and molecules that make up everything around you. It's a fundamental part of our universe, and understanding how it works and how it can be transformed from one form to another is key to understanding how our world operates. But we're not done yet. Stay tuned as we dive into nuclear light and sound energy in our next segment. Let's move on to nuclear light and sound energy. Nuclear energy is a force to be reckoned with. It's the energy released during nuclear reactions, such as nuclear fission, which involves the splitting of atomic nuclei, or nuclear fusion, where atomic nuclei combine. This energy is immensely powerful. It's what fuels the sun and stars, giving them their heat and light. On Earth, we harness nuclear energy in power plants to generate electricity, providing power to homes, businesses, and entire cities. Next up, let's shed some light on radiant energy. Also known as light energy, it's a form of electromagnetic radiation that's visible to the human eye. But it's not just about illumination. Light energy is emitted or reflected by objects and is essential for vision. It's also fundamental for photosynthesis in plants, turning sunlight into chemical energy for growth. And let's not forget about technology. From solar panels converting sunlight into electricity to fiber optic cables transmitting data at the speed of light, radiant energy plays a pivotal role. Last but not least, we have sound energy. This is the energy produced by vibrations traveling through a medium, be it air, water, or solids. These vibrations create sound waves, which our ears pick up and our brains interpret as sounds. From the gentle whisper of the wind to the roar of a jet engine, sound energy is all around us. It's crucial for communication, both in nature and among humans. In technology, sound energy is used in various ways. Think about ultrasound imaging in medicine, sonar systems in submarines, or even your favorite song playing through your headphones. From the nuclear reactions in the sun to the sound waves in the air, energy takes many forms. Finally, we have mechanical energy. Now this is an interesting one. Mechanical energy is like the all-rounder in the world of energy. It's essentially a combination, or rather, the sum of kinetic and potential energy. What does that mean, you ask? Well, let's break it down. Imagine you're on a roller coaster at the peak of a heart-stopping rise. At that point, you've got a whole lot of potential energy. Why? Because you're up high and gravity is just waiting to pull you down. Now, as you start that exhilarating descent, your potential energy begins to transform into kinetic energy, the energy of motion. And voila, that's mechanical energy in action. But let's not limit ourselves to roller coasters. Mechanical energy is at work in a multitude of places. It's in the moving parts of machines, powering gears and pistons. It's in vehicles, pushing cars down highways and bicycles along paths. It's even in the simple act of throwing a ball or the complex process of launching a rocket into space. These examples illustrate how mechanical energy, this combination of motion and position, keeps our world moving. It's an integral part of our daily lives, powering the tools we use, the transportation we rely on, and even the fun we have. But let's not forget, mechanical energy is just one piece of the puzzle. Each type of energy we've discussed today, from kinetic to potential, thermal to electrical, nuclear to light, and sound to chemical, plays a vital role in the grand scheme of things. They intertwine, transform, and transfer to power the natural phenomena, technological processes, and human activities that make up our universe. So there you have it, a whirlwind tour of the fascinating world of energy. Remember, whether it's kinetic, potential, thermal, or any other form, energy is the driving force behind every activity in the universe.